All right, now we're on the back of our study guide, and we're looking at number 5. The number one thing you want to do when you're reading the instructions is understand the instructions fully, because some of you will do this and you will miss out on exactly what it's telling you to do. It says describe the geologic column. Your description should include stratigraphic, so you should have that word in your description. You should have information about the law of superposition. And you should have how it relates to the earth. God bless you. What is the geologic column, though? Let's make ourselves some little notes if this were the test. You can do this. This is perfectly fine. What is the geologic column? See if you can do it without looking at your notes for just a second. See if you can kind of think of it, and then let's go back to our notes and look. Rogerlyn. You got to sit up. I can't hear you with your face down like that. Okay, so she says an arrangement of rocks where what? The oldest rocks at bottom and youngest on top. Okay, so you do have an arrangement of rock, but remember it's the geologic column. What else is it doing? Jayla. Not absolute, because we're talking about youngest and oldest. Telling the relative what? Age of what? Of the earth. So we made ourselves a little note. We've included information about the earth. Have we included law of superposition information?
Yes.
Yes, we just have to stick that word in there somewhere. Where would we put that? Where she said what?
Where the oldest rock is at the bottom.
Yep, oldest rock is at the bottom and youngest is at the top. Did we mention anything about stratigraphic?
Yes, we did.
We did mention it. We didn't put the word in there, but where would stratigraphic be talking about here? That's not important right now. Madrika, put your paper on your desk. You can work with it just like that. Where was stratigraphic mentioned in this information that she gave us? What is stratigraphic? What is that? Madison. Sections of rocks or rock pieces of rock layer. Where was that mentioned in her description? Arrangements of rocks. So now we can use our notes because now we know what all of these things mean and we've identified it in here. So now we can use our little note, our little test cheat sheet that we made, which is perfectly fine that you can do. And now we can come up with the description. It's asking about the geologic column. So a geologic column is what? We want to say arrangement of rocks, but we need to include stratigraphic. It's a stratigraphic, and we can put that arrangement of rock layers. What? Ordered according to the law of superposition, where nope, we got some information. We have to explain what that law of superposition is. Where
the oldest rock is on top of
the what? The oldest rocks are on the bottom and youngest on the top. It's not too much. You're doing exactly what the question is asking you. So are we done though?
No.
We got stratigraphic in there. We got law of superposition. So where the oldest rocks are on the bottom and the youngest are on the top.
That was the way to age of
Explaining or telling the relative age of the earth. There we go. This is a good explanation. However, the question needed you to include stratigraphic, law of superposition, and relates to the earth. This is a full explanation according to what the question is asking you. So not only this explanation is scientific information, but it also helps with ELA standards, helping you to fully explain yourself based on what the question is asking you. Also, civics and economics, you'll have to do things like this. And even in math, understanding a word problem, maybe even breaking it down. Moving on to number 6. The geologic column is used for what? Guess what you just did? What did you just do prior? What did we do prior? Number 5. Did we answer this?
Yes.
We did. So what is the geologic column, Simon? It says the geologic column is used to do what? Go ahead, Simon. Tell me. I didn't hear you, yes. Yep, the geologic column is used to tell the relative age of the earth. There we go. Akaya, take that tape off your mouth and stop being silly. You're not making a statement in here. You're not doing that. Number 7. Where are index fossils found and what they're used for? Now, with this question, some of you'll answer the first one, you'll move on and totally skip the second question. Not fully answering the question. Take your time and slow down. Where are index fossils found, Jayla? They are in the geologic column, but that's not enough information.
There's only one geologic.
One layer, not just a column, because remember the whole thing is the column. You have layers that go this way. So index fossils are found in one, only one, we should say, only one geologic layer. Are we done with that question?
No.
No. So we did this one. Now we need to do this one. And what are they used for? Ray?
Used to find the absolute age of rock layers.
Yep, used to find absolute age of rock layer. Any questions on that? Are we good? Okay. So now we look at number 8. Number 8 is like a question from number 5, but we have to use certain pieces of information to make sure we fully answer the question. So it says, explain how paleontologists find absolute age of rock layers. We need to include index fossil, radiometric dating, radioactive decay, and half-life. Now, what is a paleontologist?
Oh.
What's a paleontologist? Christasia.
a person that studies
They do study fossils, but that's not all they do. Jamil. Studies previous life, past life remains, fossils, bones. Akaya, get that tape off your mouth. Now. So now we need to talk about absolute age. Absolute age, your attention should be up there. Absolute age is not talking about oldest and youngest anymore. We're actually talking about the actual age, billions of years, days old, months old, seconds old. No longer talking about relative stuff. So now we're talking about absolute. We need to include index fossils, radiometric dating, radioactive decay, and half-life. Which notes, who remembers which notes we use to do that? Jayla is so enthusiastic today. I love it. Which notes? Absolute dating notes, page 7. Page 8, maybe some of it, but page 7. Everyone go to page 7 of their notes and tell me where we can find a portion of this answer to help us out. Everyone should be in their notes. No one should be waiting. We're not raising waiters. We're raising workers. Patrick.
In this problem, are you to find the actual age of rock layers through the process of radiation?
Okay, we can start with that. So index fossils. Yes. No, because we already answered that up here. This is not asking the definition. It's asking to explain how paleontologists find absolute age. This is what the question says. We're not defining index fossils. He just said index fossils are, what did you say, Patrick?
Are used for actual age.
Are used to find absolute age, what?
Of rock layers.
Of rock layers
Through the process of radiation.
through the process of radiometric dating. That is not the definition, Duran. The definition is index fossils are found in one geologic column, or layer, I'm sorry, used to find the absolute age of rock layers. Now we're breaking down how this is done. We know we use index fossils to find absolute age, and those index fossils are used during the process of radiometric dating. Have we fulfilled two of our words?
Yeah.
Now all of those demonstrations that we did helps us to fulfill the next two words. So we do it through the process of radiometric dating, which allows us to do what? Yeah, but how do we do that now? Ray, help us out. Yeah, okay. Thank you. We got to finish this definition. We got to finish this explanation and add in radioactive decay and half-life.
The radioactive decay is used to determine actual age and is measured.
Okay, so how can we fit that with this sentence that we already started? Okay, so but we got to add a little bit more information because we're just throwing words in there. Index fossils are used to find absolute age of rock layers through the process of radiometric decay. Radiometric dating. And then we want to say, she said something about using radioactive decay. Using radioactive decay of what? I'm going to add that word using, good, radioactive decay of the element which is measured in half-lives. See how that makes more sense? And it included all of the stuff that we did. That's why we did all of those demonstrations with the Twizzlers and the lab that you did when you were stacking your layers. Are we good? I mean, do you understand what we've done? Does this make sense? Okay. Looking down at your layered rock that you have here, for number 10, it says we're going to answer the following questions for the below geologic column. I'm going to move this up now. Is that good? Okay. Before we do anything, let's make sure we understand how many layers we have here. Here's one. Is this the oldest or the youngest?
The oldest.
Okay. Here we have another. I would do the same thing so you see what I see. Here we have another. This is the fourth. We have the fifth layer here. The sixth layer. And then we have the last layer, 7. So we have 7 layers. We got that? Nope, we got 7. That's why I wanted to break it down here. This is 2 separate layers. So make sure you break yours down. All right, now it says list the relative age of fossils from oldest to youngest. What did we do in class that would help us to do this? What did we do in class? Duran, what did we do in class? What assignment did we do, Ray?
We do our relative ages, shape and stuff.
Okay, we did a little example for that. What else did we do?
We did the stack up lab.
You did your stack up lab. How to stack up lab, and that's where you would help you do this. So now we have to list the relative age of fossils from oldest to youngest. Who wants to take a stab at it? Someone that has not raised their hand for class. Come on. Speak up, Kwan.
Okay.
We're going to start with the oldest over here. If a question like this pops up, please do not write out the words of the shapes. Just draw the shape. It's so much easier. You don't spell X, E-X. You actually just write the X. All right, Kwan.
Okay. So the oldest is the star.
Star.
And the
Check mark.
The second oldest is the.
So let me tell the story. Stars were born. So were the check marks. Stars died. Check marks lived on. What else was born? Circle. Good job, Kwan. Check marks died. Circles lived on. You don't need to rewrite it. Kwan, what was born next?
Triangle.
Triangles were born.
Circle died out.
Circle. I already said that. Triangles lived on, and what else was born?
Rectangle.
Rectangles. Rectangles lived on, but triangles died. Then what?
Rectangles lived on.
We're talking to Kawan. Protractors or semicircles. Now, if you put semicircles or the X first, so it could be X. Jayla, sit down. I'll answer her question in just a second. It could be X or semicircle because we really don't know which one came first because they both lived on. You see that? How they both moved to the next level? But we do know that the youngest one is what? The diamond. X can't be young because it's here too.
Oh, the diamond?
The diamonds were born last, and then they died also. All of them died, yes.
Okay, I'm not getting this because so for you said the star and check mark, then the little circle thingy, but where does the triangle come in? Because the triangle is in. You don't have a comma between the triangle and the circle.
Just because I didn't put a comma, I didn't have a comma between any of them at first.
What?
You have
They're not together?
no, they're not born together, they're different organisms. These are fossils. These shapes represent fossils. They're not connected.
I thought you were just putting them in like that time period.
No, I was just listing them. Madison. No. Yes, that does matter. Because if you did this, do not write this, but if you did check and then star and then circle, according to what you're writing here, you're telling me that the check mark is older, and that can't be true because the check mark didn't even live on. I'm sorry, the star didn't live on. The star came first and it died. That was the first thing there. Yeah. If it only exists there, then the star came first. Check mark continued to live on. So make sure you put the star first. Now, if they both lived on, then you can put them in any order. All right. Let me get this back from being blurry. So again, the semicircle and the X, they can be interchanged. Come on, get focused. All right, moving on to the one that says, which, if any, fossils can be index fossils? Duran. Yes, durian. The diamond is an index fossil. Anything else? And the star. Make sure you put both. Don't just put one. Because it says which, if any, fossils. Guys, that's just why we broke it down. Look, the triangle's in layer 4 and 5. Those are two different layers. Aaliyah. It's only in this layer. Doesn't matter. It doesn't say one fossil. It says only in one geologic layer. Remember, these are organisms. It doesn't mean one organism lived in that layer. It just meant, I'm sorry, yeah, one organism. It meant one species of organisms lived in that layer. Couldn't put all the fossils there because that'd be impossible. We're just doing a little picture. Don't get confused. One meaning one fossil. It means one layer. Drika.
I got the O because the O is the only one that was in.
Nope, the O is here and it's there. It's in layer 2 and 3. All right.
But, I have another question for the first one. I got. So you don't re-put the same.
No, you don't have to re-put it because it's the same organism. All right. What method would be required to determine the absolute age of these rock layers? Did we already answer this up in like 7 and 8?
Yes.
What method would be used, Rajalen? Radiometric dating. Good?
Yes.
Turn around, Devin. If a fossil contained a fraction of 1 over 32 of an element which has a half-life of 28 days, how old is the rock layer that contains that fossil? Well, hold on. Because it's not about just getting the answer, it's about explaining, make sure everyone understands what it's asking for. Now, we do understand this whole method here, and your notes told you that if you knew the rate of decay, which is the half-life, then you could find the absolute age, correct?
Yes.
So we know that what the rate of decay is, which is the half-life. What's our ultimate goal that we're trying to get to? No?
32 or 50.
What's the goal when we're trying to figure out the age? What's the goal number we're trying to get to? That's going back. When we go back in time and we come towards the future, towards the present, what's our present goal that we're trying to get to? 1 over 32. This is where we are right now. We just dug up our rocks. We dug up our fossils. We checked the element. We found this. We have to go back in time. So we can do our little chart with our top being time. Our bottom being what? Amount. Going back in time, which means that no time has passed. What is that? 0. What fraction of the element will we have at 0 time? That's not a fraction. 1. Not 100%. After time has passed, how much time has passed?
28 days.
28 days. That's the half-life. What do you mean, huh? What do you mean, huh? The half-life is 28 days. That's the only amount of time we're going to go each time. So from 0 days, we have to move 28 days. After 28 days, how much is going to decay? Turn around, Akaya. Half-life. Half of it's going to decay after 28 days. We're only moving the half-life, the amount of time, the rate of decay. So we're going to move 28 days. After 28 days, how much is going to decay? Ladrika, turn around. Okay. What's going to be our fraction? What? 1 half. 1 half would be a lot easier, Duran. We go another 28 days, which will be a total of how many days? 56 days. What's going to be our fraction? 1/4. Are we at our present day goal?
No.
No. We go another 28 days, which is?
84.
What's our fraction?
1/8.
We go another 28 days, which is?
112.
Good, 112 days. What's our fraction?
116.
Are we at our present day goal?
Not yet.
We go another 28 days, which is 140 days. What's our fraction?
132.
Are we at our present day goal? So our answer is, our question is, how old is the rock layer that contains the fossil?
140 days.
140 days old.
140.
Kaya, come sit over here closer to me. Right now. List the divisions of geologic time scale from largest to smallest. We're not talking about the specific Precambrian and the Mesozoic and things of that nature. Those are smaller portions. We're talking about the actual divisions. We have one big division, which goes down to another one, which goes down to another one, which goes down to another one. What are those? It's geologic time divisions. Well, you should get in your notes and you should look because we called them divisions of the geologic time scale. They're larger ones. Those larger ones break down to smaller ones. Eon is the largest. Then we have era. Then we have period. Then epoch. Now we didn't come up with a acronym for this, but we could. Yeet. Yeet. Someone in the last class said Edward eats pizza every day. But I'll wait. Here's the only thing. You have to be able to remember what these E's are. You can remember in order. Maybe the last one is the longest one. Then you just have to remember eon and era. Maybe Eon eats pizza every day. All right, lastly, discuss the theories that... There are a couple of you I want to see at the end of class. Move back to your seat right now, Drika. Move. Discuss the theories that helped Earth's history. That's Earth's story. That was the very beginning thing. Give me something, Ray.
Uniformitarianism.
We got uniformitarianism. What does uniformitarianism tell us?
How it affected Earth slowly, gradually.
Yes, the Earth was formed. Gradual formation. But contrary to that, Drew, catastrophism. Okay, I'll focus it. Catastrophism said what, Drew?
That it happened more, faster, and it was usually natural disasters.
So that would not be gradual, but suddenly. It's more of a sudden formation, like natural disasters. But what was the overall assumption of how the Earth was formed? Okay, so what is that called? Modern geology. Which the Earth formed gradually, turn around, Eddie, and was interrupted by what?
Catastrophe.
By catastrophes or sudden changes. How many of you would have gotten 100 on this side? Some of you did not even have eon, era, period, or epoch, so don't lie. How many of you would have gotten at least an A on this side? An A on the whole test. Okay? No, it's E, E, P. This isn't O. This isn't O. It's just this isn't O. It's just the way my circle was made. All right, so you want to make sure that you study.